Okay, hi guys. So from the previous lecture, I think I gave you some homework to actually determine why the product form in the previous reaction was not as desired. Okay, so we'll see into that first. So what actually happens in that reaction is, let me rewrite that reaction. We had something like this, and we are here, and we are reacting it with first. We are here, and we were reacting it first with first Mg in presence of ether, not Hg. Mg in presence of ether. Second, formaldehyde, and third, H plus. So what actually happens is, if you first look at the Grignard formed, this would be the same. So at this till this point we were actually right. But now what later happens is, we have acidic hydrogen present here, which is attached to nitrogen. So what actually happens is, um, this is acidic hydrogen, and in this case this carbon atom acts as a base. So intramolecular acid base reaction happens. Intramolecular acid base reaction happens, in which what we find out is, this C minus actually attacks on this hydrogen to form a CH bond here with a negative charge here, and Mg plus we are attached on negative N. Okay, so now second, when it undergoes HC double bond OH, what actually happens is, this nitrogen actually attacks on this carbon atom, and we get something like CH2. Then we reacted with, this was the second. The third, we actually pass H plus, so we get something like CH2OH as our product. Okay, so due to the intramolecular acid base reaction, this compound we found instead of, we saw previously, this CH2OH. So this was not formed, instead this was formed. Okay, because of intermolecular acid base reaction. So just keep in mind that we cannot prepare Grignard reagent in which we have the tail of Grignard having acidic hydrogen. Okay, so let me rewrite it here, that we cannot prepare Grignard in which we have tail of Grignard having acidic hydrogen. Having acidic hydrogen. Okay, so let us see what actually happens in this reaction. We have something like this. We are on adjacent carbon atoms, and we react it with Mg in presence of ether. So we get this as our product. Now how does this happen? What actually happens in the first step is, we get something like MgBr here and a Br attached here. Now what actually happens is, this has partial negative charge and this has a partial positive charge. This carbon atom attacks on this carbon atom to form a double bond, and as a result this Br withdraws its valence electrons and also takes the carbon's electrons, this carbon's electrons. So we get something like this as our compound. Okay, so now let us see the reactivity of the next topic. Is we have to see the reactivity of following compounds towards nucleophile. Specifically, in our scope, we are saying for now, for the time being, Grignard reagent. Okay, so what actually happens in this is actually important, and you must remember this, that this has the highest reactivity rate than aldehyde, which has higher than ketone, which has higher than RCOR, which is higher than RCl. So why is actually RCOR rate lesser than RCOCl? Because when although we have that HCl is a stronger acid than obviously ROH, hence Cl minus would be a weaker base, or then OH minus, which is a stronger base. Okay, and weaker base is a good leaving group, and OH minus would be bad leaving group. Okay, so this is the reason that we get something like this. Okay, and also we can say, obviously for RCOCl and alcohol it was fine. Okay, similarly we can see for other groups as well. We can compare the acidic rate, so acidic rate, and then we can see which is a good leaving group or a weak base. According to that, this reactivity rate is defined. Also we have plus m of this O into the picture, hence which also makes this carbon atom less partially positively charged, hence this would be a bad place for a nucleophile to attack. Okay, we can see in other words that acid chloride is most reactive towards nucleophile. Okay, now let us see some examples for the same. We have something like this, and this, we have a NO2 group also attached here. So if we see that we need to compare the reactivity towards Grignard reagent of these two compounds. Okay, so one way of looking at this comparison is, first let us see that, okay, in this case we have a plus m effect, so that this carbon atom is having less positive charge or partial positive charge, but in this case this would actually be getting involved, the lone pairs would be more involved in having resonating structure with this compound, because this is having a minus group attached to O group. Okay, so this would be having more partially positive character, hence it would be a better candidate for nucleophile to attack. So with the first approach we see this as the comparison. In the second approach we can see that you have to tell me that which is a better acid than the other. So obviously NO2 would be a better acid. Why? Because of the presence of a minus M group, hence O will more generously donate H plus into the reaction. So this is the acidic order. So this is a weak acid, this is a strong acid. Conversely we can say that it's a good base, it's a weak base, or rather strong base, it's a weak base. Okay, if it is a strong base it would be a weak leaving group. Okay, and if it's a weak base then it would be a good leaving group. Okay, now as this is a good leaving group, okay, so now what happens is, as this is a good leaving group, nucleophile will be more interested in attacking on this group. Okay, so in this case this was the acidic strength, and in this case this is the nucleophilic reactivity strength. And from both the cases, case 1 and case 2, we see the same thing. Okay, hence this is a better candidate for nucleophile to attack on. Okay, so next we'll be seeing reaction of the below mentioned compounds towards Grignard reagent. Okay, so we will see reaction towards Grignard reagent. Okay, so we have compounds like, this is obviously called aliphatic aldehyde, this is aliphatic aldehyde. I'm just giving a generous name, this is no very related to a common name or a IUPAC name. This is the generic name I'm just giving for the understanding purpose. Okay, second we have something like this, which is obviously a aromatic aldehyde. Now we have something like this, which is aliphatic ketone. Now if aliphatic is in the picture, we'll also have aromatic ketone. So this is aromatic ketone. Okay, next we can also have something like this, in which I have something like this, which is a benzophenone. Okay, so we need to compare the rate of reaction towards Grignard reagent. Okay, so as you can see, this there is a phenyl ring attached here, so it can give plus M to this carbon atom. It would be less positively charged. Okay, and then actually plus M effect actually happens on here, where we have the double bond is between these two carbon atoms, and eventually it will go to O minus. Okay, next we'll be having something like this, which would be having a partial positive charge, which would be obviously lesser than the previous compound. Okay, because the plus M is for between the bond between C and O, and but this phenyl ring actually exerts a minus I effect also on this carbon atom. Okay, well, but in this case there is a plus I effect on both the sides. Okay, similarly the same can be seen for this case, where we have one hydrogen here and one CH3 here. So obviously this is having a plus I effect on this carbon atom. Okay, and in this case from both the sides we are having plus M effects. Okay, and not to mention that this will also have a plus H effect. Similarly this both would be having plus H effects, which would be more considered, and the plus I effects would be seen, but first would be plus H effect would be seen. So this is actually having 5 alpha hydrogens. This is actually having resonance or plus M group attached to itself, and and has 3 alpha hydrogen. This has two resonating structures. Okay, so this would be the least positively charged carbon atom. So the rate would be, this would be the least. Then obviously for this we have resonance plus 3 alpha hydrogen, and which would actually overwhelm the partial positiveness on this carbon atom, hence this would be less partially positive, hence a bad candidate, or relatively bad candidate when compared to this, hence this would be the order. And when we compare on this is actually having only one resonating character, okay, or 1 plus m. This would be having more positive charge, and this is actually having only 3 alpha hydrogen, okay. So no resonance stability on the carbon atom, hence this would be more positively charged, hence this would be the rate. So this would be in the decreasing order, okay. So with this we come to the end of this lecture. In the next lecture we'll be seeing more such examples on Grignard reagent and the reactivity of compounds towards Grignard. So till then, good luck and goodbye.